Hello and welcome. My name is Gregorio. I'm an electrical engineer, and in this video series I'll be introducing you to the wonderful world of coding. And the way we'll be doing that is by looking at how code can be used in creative projects involving things like media, music, art, and games. So we know that code is everywhere. It's hiding behind every website you've ever been on. It's inside every electronic device you've ever used. This ranges from the complexity behind your phone and your computer to the much simpler code that runs on things like the appliances in your house. So in this video series, we'll be getting our feet wet with what we call creative coding. And if you enjoyed doing all the things that you learn in this series, you can continue down this path and you could go on to build skills that you need to make things like video games, escape rooms. You could design interactive websites. You could create visual art with tech like projection mapping. And you could even make some of the strangest musical instruments you've ever seen. So in the next video, we're actually going to start learning how to write code. But to start, it's important to have some context and know a little bit about why we're using the tools that we're going to be using. So the question is, where do we start with creative coding? So there are hundreds of programming languages out there. And there's a huge space of possibility that opens up when you pick up a few skills and you integrate them with your other skills. And there are projects that can be done entirely with code. And there are projects that can use coding as sort of one tool in the kit alongside more physical things like 3D printing, wood and metalworking, and embedded computers like the really popular Arduino microcontrollers. These can serve as a bridge between your code and the physical world. And they're great for things like robotics because you can read data from sensors and control things like motors and lights. So even though we're all stuck at home and we don't have access to the materials we need to make these cool interactive physical projects, we'll still get our feet wet with creative coding and explore some of the possibilities on the software side. So in this video series we'll be building a game that I call Bounce. In this game you'll control a bouncing ball using the arrow keys, and you try to break blocks without falling through to the bottom edge of the screen. We're going to be doing this in a language called JavaScript, which is a language that's used all over the web. JavaScript is also similar in a lot of ways to a really common language called C, which is what people use to program things like Arduino microcontrollers. So if you're more interested in making things like robots than making games and websites, it's still great to learn JavaScript because you'll have a leg up when it comes time to learn the C language. This is because there are tons of programming concepts that are not specific to any language. It's kind of like if I wanted to learn Spanish, there are still going to be things like nouns, verbs, adjectives, adverbs, and knowing all this stuff makes it easier to learn the language. So what can JavaScript do? JavaScript is one of the three most common languages used in web programming. It usually appears alongside HTML and CSS. So in a nutshell, every time you visit a website in your browser, the site's HTML code tells the browser what's on the page. CSS describes how to style that content with things like colors and fonts. And then JavaScript handles all the user interaction. So like what happens when the user clicks on a button. So it takes a bit of knowledge across all these three languages if you wanted to, for example, build a website from scratch. But that's not where we're going to start because luckily there are a bunch of websites out there that allow us to edit and run JavaScript code entirely in the browser. And we don't have to worry about things like HTML and CSS. So we'll be using a website called processing.js. This website provides us with two really important things. One, it gives us a code editor. And two, it gives us a really useful code library. So what exactly is a code library and why is it so useful? In the upcoming videos, we'll see some examples of what exactly the library does for us, but it's a pretty simple concept and we could understand it with an analogy. Okay, so say you owned a restaurant and you were training a new server. If you needed to instruct your server to, say, get a glass of water for a customer, you'd have an uphill battle ahead of you if you had to give instructions like exit the dining room, enter the kitchen, walk to the glassware cabinet, open the glassware cabinet, retrieve the glass, etc. you'd be thinking the server should know how to do all these tasks, and I should just be able to put a box around sets of these low-level instructions and then give them higher-level labels so that the server knows how to do all these things when they need to retrieve a glass, fill it with water, deliver the glass to a customer. Then, once the server has all these procedures down, we could put another box around those instructions and make even higher-level instructions out of them. So in programming, we have a name for this process of packaging up sets of instructions so that they're easy to use and that you could think in these high-level terms. We call this abstraction. When we put a box around a set of instructions, we're saying that at some point the programmer should not have to think about how the server gets a glass of water in this analogy. The programmer should just know that they can say, go get a glass of water, and the glass ends up on the customer's table. And then they can move on to the next higher level task. And this is essentially how programming works. So when we build a program, we often start with these lower level tasks, and then we encapsulate them, and then we work our way up to doing higher level tasks. So you might say, okay, that's great, but what does all this have to do with code libraries? So oftentimes, these low-level tasks are things that a lot of people have to do as parts of their programs. So software developers seek out code libraries that can take care of these low-level details that they don't want to have to worry about because it takes a lot of time to reinvent the wheel. So if somebody's already done it well, and it's out there on the web, and you can use it, then you should. Now we could look at an actual programming example, and let's take the game that we're going to build. So a part of what we have to do is, say, draw a white circle on a black background. If we wanted to do this at a very low level of abstraction, we'd be doing things like scanning through every pixel on the screen and trying to figure out which pixels should be black and which pixels should be white. And that sounds pretty tedious. We'd have a much easier time, and we'd be way more productive at a higher level of abstraction where we could do things like change one number to increase the size of the circle, and we could do things like change another number to move the circle horizontally across the screen. Those are the kinds of instructions that we want to work with to build our game. And you might have guessed that this really useful library that openprocessing.org gives us is one that does exactly all this. It makes it easy to do things like generate computer graphics and to know when somebody presses a key on a keyboard or moves the mouse, so you can make these graphics interactive. This library is called P5JS, and it's documented really well, so as we learn JavaScript and work through our examples, you can always refer back to the code reference and see which parts of the library handle things like changing colors, making shapes, managing data, knowing what the user is doing with the keyboard and the mouse, and even more advanced graphical things like making virtual light sources and shading. It's all here in the reference, and you could click through on any of these to learn how each part of the library works, and you could see examples of how it's done. So before moving on to the next video, I really highly recommend you go to openprocessing.org, and you can look at all the example projects that people have built using JavaScript and P5JS. Some of these projects are abstract, some are interactive, there are all kinds of games, and even video effects. There are even epidemic models that show how COVID-19 can spread when people practice social distancing and when they don't. So to summarize, you probably knew that coding is used by programmers, engineers, and scientists, but it's also used by artists and musicians and other creative people as well. In the upcoming videos, we'll learn how to program using the JavaScript language and the P5JS library. And we'll be editing and running our code on openprocessing.org. So you could go there now and create your free account and browse through the example projects. So thanks for watching, and join us in the next video where we'll get started writing some code.